Hello everyone. First of all, I have the pleasure to participate in the 9th International Renewable and Sustainable Energy Conference 2021 with this oral presentation titled Municipal Solid Waste Generation from Morocco and Tunisia and their possible energetic valorization, realized by me Souad Aboudaoud and supervised by Professor Souad Abderafi. The plan of our presentation is as follows, starting with an introduction to define the context and the objective of our issue, then a characterization of Moroccan and Tunisian municipal solid waste was carried out. After, we will introduce the different waste to energy recovery technologies, finally a conclusion and perspective of future research. As we know, municipal solid waste management is one of the major challenges facing the world. In Morocco and in Tunisia, the almost unique approach adopted for the disposal of municipal solid waste is as follows: collection and storage of waste, transfer and transportation to sorting and recycling centers, and then its disposal in landfill. Due to the lack of an efficient exploitation of the solid waste as a renewable energy resource, we are currently working on a research and development project within the framework of the Moroccan-Tunisian cooperation, where we seek to develop an efficient industrial process of valorization of MSW to produce bioenergy with an optimization of the energy consumption and the obtaining of a high output and without environmental impact. In Morocco, according to 2019 statistics, the total production of household waste is 6.8 million tons, and it will increase significantly to 9.4 million tons by 2030. In Tunisia, the amount of MSW generated is 2.6 million tons per year. The estimated growth rate is 2.5% per year. The composition of the waste is almost similar in both countries. It is characterized with a high moisture content, and it is constituted by a high quantity of biodegradable waste and a significant percentage of 20% of combustible solid waste with important calorific value like plastic, paper, cardboard that can be recycled and energetically recovered. In their strategy targeting energy recovery and waste reduction, Morocco and Tunisia have generally resorted by biochemical means such as bio-methanization due to the domination of fermentable waste. For example, in Tunisia, they have implemented a collection and treatment of biogas programs at the controlled landfills and some methanization units at certain agricultural complexes. In Morocco, several cities are involved in different energy projects for the biological recovery of MSW. For example, in Rabat, we have a large sorting center called Ommezza, which recovers organic waste by producing biogas through a system of treatment and conditioning of biogas. Indeed, although the recovery of biogas from landfills is technically simple and economically cheaper and environmentally friendly, these gases are not produced in a continuous way because their generation takes long periods, as well as landfill gas collection systems cannot recover the full amount of methane. Scarlett et al. Estimated the potential of energy recovery from both incineration and landfill biogas processes in Morocco and in Tunisia. He found that Morocco and Tunisia has energy recovery potential by thermochemical processes very important and largely profitable compared to the recovery potential by biochemical processes. So it is necessary to exploit this potential through the installation of thermochemical conversion units adequate and more ecological. Morocco and Tunisia are recently registered in project of recovery of non-fermentable fraction called refused derived fuel through the mechanical biological treatment centers. This fraction is used as an alternative fuel to the fossil fuel in the incinerators of cement plants. Nevertheless, incineration has a bad social ecological reputation because it generates gaseous effluent highly polluted with heavy metals and as well as fly ash particles. However, after further processing, this dry waste can also be recovered into ecological products by pyrolysis or gasification process. Gasification is a complex process for the thermochemical degradation of solid matter at high temperature. It has good control of organic and inorganic polluant emission. It favors the production of clean combustion gas, but it has a problem with the equipment corrosion due to the oxidation at a high temperature and the tar's presence as a byproduct. Pyrolysis is an endothermic process for the solid matter thermochemical degradation at low temperature in absence of air. It favors the production of good yield of bio-oil for transport and the production of biocarbon and syngas with a high calorific value. It is a more ecological process with low emission of polluants. Furthermore, Several scientific research have shown that pyrolysis of mixed waste allows to increase the quantity and the quality of the bio-oil produced. So we can conclude that pyrolysis could be our appropriate choice. In conclusion, pyrolysis is the most environmentally friendly choice for energy recovery for MSW. It is a new development technology which has shown good performance at laboratory scale, but it still encounters difficulties in its scaling up, which we aim to overcome in our research project. As further research, the choice of the raw material and the reactor technology is essential, aiming to reach a maximum performance of the pyrolysis process to produce a considerable quantity of bioenergy with a quality compared to that of fossil fuel. That's all, and thank you for listening.